Good afternoon, ladies and gentlemen. Thanks for your interest and participation in our Industry 4.0 webinar series. Right, in this series, we have 5 parts, and today will be part 1. The topic that we will be discussing today is Industry 4.0, how to prepare and start out in difficult times. In current pandemic situation, digitalization and embarking into Industry 4.0 has become more vital. Right? Therefore, we have invited Dr. Hoffman from Germany to give this talk. A little introduction about him. Dr. Max Hoffman is the head of digitization and digitalization manager at the Institute of Production Technology, or in short, it's called IPT, which is part of the Fraunhofer research organization. For numerous years, he has been leading the industrial big data group at RWTH Aachen University and managed major projects with German manufacturing industry. Dr. Hoffman conducted projects on digital transformation with many large-scale German and international companies such as Volkswagen, Porsche, Saint-Gobain, and Bosch. He will be giving talk for 45 minutes today and followed with another 45 minutes for Q&A. So please raise your concern or questions in the chat box. Myself and my team will compile them and raise to Dr. Hoffman on behalf during the Q&A. We will try our level best to cover all the questions as much as possible. And without further ado, here's our speaker for today, Dr. Hoffman. The screen is yours.
Yes, thank you very much, and welcome you all to the session today on Industry 4.0, how to start out in difficult times in which we are right now. So let me just jump into the topic. Thank you, Raghavan, first of all, for the introduction, very kind. And let me start how you can benefit also from steps you can perform right now to bring you in a better situation when we get better times again. So what is happening right now? The news are full of bad news right now. As in Germany right now, we have many difficulties in our traditional sectors, in our traditional products, in our traditional value chain. Yeah, we have travel bans, we have a lot of controls. Companies are in danger. For example, some companies might have to merge. Is very difficult, but also Malaysia unveils a stimulus package, yeah, to fight against unemployment, to fight against the problems that we have in the industry right now. And I would like to talk to you today a little bit how you can use this crisis we have right now to strengthen yourself, to be better after than you were before, and how you can use the time right now to build up new business models and to build up new ways how to deal with data and how to deal with digital transformation. So being that said, this citation here from the year 2015 is now more true than ever. It says coping with digital change is the most important management task of our current time. If the business model changes as a result of digitization, the company must adapt or disappear sooner or later. Even right now, the digitization is even more important than ever. We have to work from home. We have to digitalize our solutions. We might even have to automate more because there can less people be in the production and work. Yeah, we need to adapt to this digitization, which is forced on us right now. Yeah, and I would like to show you how you can use this digitization to cope up with the challenges and to come up with ideas for Industry 4.0. So, but what really is Industry 4.0? Let's quickly examine what the first industrial revolution till the fourth industrial revolution means. The first industrial revolution was the development of the steam machine. It was the first device that was able to transform chemically bounded energy into electrical energy and into mechanical energy. Then, as a second industrial revolution, we had the centralized power plants. What was the main difference between the first and second revolution. Both revolutions involved energy, but we had a transition from local to global. We were able to share the energy that we produce on a global level. Before, with a steam machine, the steam machine has to drive with a locomotive to power the train. Now, with power plants, we can distribute this energy nationwide. So we have a transition from local energy to global energy. So what happened in the third industrial revolution? It is called the digital revolution. This is when production plants got automated. We invented robots. We used machine-to-machine communication technologies between machines, robots, and systems. And we made automation. So what's the main difference between the third industrial revolution and Industry 4.0? The difference is that right now we are also going from local to global again. Now with Industry 4.0, we are finally lifting the automation on a global level. That means we would like to automate from remote. We would like to use solutions that we have from the internet. We want to create something that we call an Internet of Production. It means that all devices, all machines, all sensors, and control devices are connected to each other and are remotely controllable. When we reach this, then we can even benefit from the situation that we have right now. So, but what is Industry 4.0? Let me explain you the cornerstones of Industry 4.0 by giving you some examples of applications and projects that we already have and that we already pursue at RWTH Aachen University. When we look at Industry 4.0, we can look at the 9 pillars of Industry 4.0. These 9 pillars mark the basic revolutionary technologies that we are able to use right now as we have Industry 4.0. These 9 revolutionary technologies are big data, Internet of Things, augmented reality, cloud computing, autonomous systems, smart robots, additive manufacturing, universal integration, and advanced simulation. Let me briefly introduce to you all of these pillars by some examples to show you what these technologies are capable of in terms of an Industry 4.0 environment. So let's start with the Internet of Things. Yes.
Sorry, Dr. Hoffman, sorry to interrupt, but are you sharing your screen?
Oh, I'm so sorry. Why didn't you say it in the beginning?
I thought you just wanted to give introduction, but it's okay. Continue.
Okay, there was a technical mistake. I will show the slides right away. I'm sorry. Okay. Yes.
Probably you can just go a quick recap again, slightly.
So okay, yeah, we talked about difficult times in Malaysia, which we have right now, but we also have these programs which are able, which maybe gives us a chance to deal with the situation. And the coping with the digital change is very important, as being said. The company must adapt to this changes which we have right now, and must introduce digitization, or the company must adapt or disappear. And we had the first industrial revolution with the steam machine, the second industrial revolution with the electrical power plant, and this transition from local to global. We will also have in a transition from the third to the fourth industrial revolution, where we lift the data on a global level. Yeah. So let me show you again the slide, which is basically the starting point of our presentation, which shows the 9 pillars of Industry 4.0 and how we use them at RWTH Aachen. We already went through the 9 topics, which were big data, IoT, augmented reality, cloud computing, autonomous systems, smart robots, additive manufacturing, universal integration, and advanced simulation. Yeah? Let me start with the Internet of Things. What does this really mean? So here you see a map where you see the internet in real time. You see how much gigabyte Facebook generates every second, how many tweets are being tweeted on Twitter, how many WhatsApp messages are being distributed, and how much money companies like Google make with ads. In the bottom, you even see the number of cumulated data, and you see that in 30 seconds, we generate 2/3 of a million gigabyte of data. So this is the speed of the internet. And this is the speed of the internet, which is currently only used by the people. Let's imagine that every machine in a factory and every device and every sensor will be part of the internet and constantly distribute information. Distribute information, and we need to store these in databases. So we have to deal with a lot of big data. One problem even more is that the systems in factories have been grown over the last 20 years. We have many different systems for quality insurance, for enterprise resource planning, manufacturing execution systems, and we also have data that comes from the field, from the product usage data. Let's imagine every phone that is being produced, every car that is being produced sends data back home. And we also need to deal with this data. So the first thing we need to do in order to start out with Industry 4.0 is to understand the data that we have and to understand the systems that we have. One major project which is running in Aachen right now is a so-called excellence cluster, Internet of Production. And this describes precisely what the big challenge of Industry 4.0 is. We would like to use Industry 4.0 solutions on the whole life cycle of production and manufacturing. We have the development cycle, we have the production cycle, and we have the user cycle. On each of these different cycles, we have different systems. We need to structure this information and integrate this information through some generic middleware to finally get the decision support systems on the top, which will tell us when to maintain a machine, how to optimize production, how to prepare better for customized products, and how to deal with special situations. The next important pillar of Industry 4.0 is big data. And big data is, like you've seen before, in terms of Internet of Things, very important because all of these devices produce a lot of information. And we have to differentiate between traditional big data and industrial big data. While the traditional big data from the internet is human-made, the industrial big data in our factory is machine-made. Though the human-made big data is unstructured, while our industrial big data is structured, this structure of the industrial big data is very complex because we have many different protocols, many different devices, we have many different machines and PLCs and so on. And we need to deal with this brownfield. We need to deal with this grown infrastructure of different systems that have been developed over the last 20 years. One mean to deal with this is a so-called data lake application. The data lake serves as a generic database for company-wide data. And the data lake is not a real lake with zeros and ones in it, like visible here. A data lake is a generic storage which can carry many information from different systems, like all the systems we've seen before, from enterprise resource planning systems, from quality management systems, from ERP systems. Yeah, they can carry enterprise data and also extra enterprise data. That means using this data lake, we can actually combine the data we already have in our company together with the IoT data from the field, from the cars that's sending back their data home, from the mobile phones that's sending back their data home, and so on. When we have this data lake structured, we can send queries to the data lake and get reports, exports, perform analytics, make optimizations, create KPI cockpits, key performance indicator cockpits, where we can optimally see what's going on in our production, where are optimization points, and how we can deal with them. The perfect data lake is extensible. It means it can grow with the production or with the data. It's accessible. That means we have a generic interface where we can use and get all these reports, exports, and analytics, and is searchable. Yeah, the ideal company database is searchable like we can search web pages with Google. Augmented reality is another important cornerstone. Augmented reality can help for teaching, can help for robot training. Augmented reality can help of seeing the problem, and seeing the clue. There's also many projects going on in this field. Cloud computing is the next big field of Industry 4.0. In cloud computing, we would like to integrate all the information we have in the field from the machines, from the sensors, from the devices into some sort of company cloud. This company cloud offers then services like optimization of our enterprise resource planning, optimization of our manufacturing execution systems, optimization of logistics and IT services. This integration layer in between the machines and this cloud often is a complex infrastructure of different PLC, programmable logic controllers, communication devices, and server client structures. We need to start now to understand the interfaces of our machines, to put the data from the machines in our cloud. And this cloud doesn't need to be a public cloud. It can also be a company cloud which offers these services, which has these systems, and which can be used to optimize the production in a sort of holistic way. Advanced simulation. Advanced simulation offers us new services and new ways of dealing, for example, with data. Here we see this is so-called cube of the RWTH Aachen. This is a 3D hologram simulator, which is basically a box in which 3D objects can be placed in the middle. And the human eye is normally only able to see three-dimensional data. The human eye can normally not see more than 2D or 3D dimensions. With this device here, we are able to show, for example, as in this picture, 9-dimensional data through these metadata views, what you see in the middle of the picture. So this advanced simulation we can also use to actually deal with the challenges which digitization brings us right now. Universal integration, what does this mean? Universal integration means that we can get all the data from our machines, from our devices, also from people working in the field, maybe based on smartphones, maybe based on smart watches, and integrate this information in one factory cloud. Again, this factory cloud can be local in our company or can also be a cloud provider. When we integrated this data into the cloud, like what we've seen before, then we can finally ensure the vision of holistic and a network production. We would like to reach a holistic optimization of our production. So as you see in the bottom left here, we have the machines which are already connected. They distribute their data in a company cloud, as seen in the middle below. From this company cloud there, we can either generate reports, dashboards, show KPI performance indicators, and can give the user an opportunity to use this information to make appropriate and good decisions. In the same time, however, we can also use the company cloud to use autonomous optimization and algorithms. Here you see, for example, a neural network. And together with the humans and the artificial intelligence, we can reach something that is called holistic process optimization. That means we have the combined power of the computers, of modern AI applications, and of the experience of the user to adjust our parameters of the production in the best possible way. This circle here, this cycle, is the way how production is optimized in Industry 4.0. And there is a couple of steps to be performed to reach this vision. Later, more about this. One trend as well is additive manufacturing. Right now, as maybe deliveries become more difficult or getting replacement tiles or components becomes harder, additive manufacturing or 3D printing becomes a new way of ensuring process stability and getting the components. But also 3D printing can be used for very precise components. Here, for example, you see a component from the colleagues of mine where they print steel or ceramics in a micro scale. Here you see, for example, a gear, yeah, which is very, very precise and very, very small. This is the size of a cent coin. Smart robots is also very important. Yeah, I'm proud to mention that we at RWTH Aachen University are actually world champion in the Robot Logistics League, where we program autonomously navigating robots to make challenges against other teams and play tournaments against other teams. These robots will be the future in production and bring products which are being produced from one machine to the other. Last but not least, autonomous systems. In the modern world, we are used to services. We are used to services that just function well. For example, we are used to use Google Maps, for example, for navigation. Yeah. When we look at products right now, which are produced by the industry, many of the products which are already around for many years, like for example the car, as shown here, doesn't offer the same services we already have in our daily life. Why can I not use the same GPS system in my car right now as I can use already on my phone? Yeah? So there is new requirements on the companies, on the industry, because the people expect more. The people expect more convenience, yeah, and the companies which produce consumer articles, for example, like a car, they cannot afford anymore to not offer this convenience. This is why new companies try to build the same technology like we already have on our smartphones, on our laptops, in modern devices to give the users the feeling that they can deal with a system that just works and they already know. So what are really the application areas of Industry 4.0? What can we actually use it for? Yes, of course, we can use it for optimized quality assurance. We can use it for the so-called batch size 1 production, which means that each product which is manufactured is actually unique. We can use it for decision support, reduce process runtime, minimize process errors, minimize ramp-up costs, for example, when we want to build up an additional manufacturing site, and use it for smart maintenance. And maintenance is a very important field because the classical maintenance, I fix a machine when it is broken, is very expensive because it induces usually downtime. The preventive maintenance, which is performing maintenance in fixed cycles, is also expensive because it might happen that you replace a component which is still working very well, and then you waste this component. This is why we have predictive maintenance right now. Predictive maintenance means I will only fix a machine or a device when I see in the data that the likability it will break rises. That means we reduce downtime, but we also don't throw away machines or components which are still working fine. So these are some industrial partners we've been working with in RWTH. And here you see many big companies. Yeah, most of the actually big German car manufacturers, like already mentioned before, like Audi, BMW, Porsche, and so on. But also in silicon industry or in telecommunications. Yeah. We've been working with these partners in many different projects where we performed big data in mechanical engineering, applied machine learning, and ICT. It means information and communication technology for creating hybrid machine infrastructures. We also try to bring the human in the process. Yeah, we make so-called human organization technology digital transformation projects. It means we try not only to introduce new technical solutions, we also try to make the human understand why it's better for him to use this and why he can benefit from this and how in his work he can maybe become more responsible and maybe he can have a bigger impact on what he does every day. We also do a lot of projects in didactics and of course, as mentioned before, in mobile production logistics where we are the world champion. So what is really digital transformation? Digital transformation is the combination of changes in strategy, business model, processes, and more than ever, culture and companies through the use of digital technologies with the aim of increasing competitiveness. To obtain this digital transformation, we need all stakeholders involved, not only the SMEs, but most importantly, of course, but also science and research for teaching. For example, what I do in a lot of trainings, which we already delivered in whole Malaysia. The government funds this project, and we have individuals and communities which also add a very high value to the solutions that we have, especially for digital solutions like new interfaces, new web interfaces, yeah, and systems that are free of use, systems which are open source and which can majorly transform the way we work and the way we deploy new solutions. So what is the Industry 4.0 maturity level? Which means, how do I get there? So to get to all these applications, which I just shown, you need to perform a couple of steps to bring your company on the level that Industry 4.0 is actually deployable. The first step that we need to perform is the data readiness, yeah, the connectivity of machines. In the later steps, you actually create a big impact where you create analytics and prediction. So the first step is a computerization. You need to make sure that all your devices and machines are connected. Then you need to perform visibility of your machines and transparency. You need to store the data in a way that you can access them, that you can use them, that you can extract them for analytics. Based on that, you can finally develop prediction models. For example, you can develop a prediction model. When is my machine to be fixed? Yeah. A prediction of each product. What can I adjust in the current production process because my product may be a fail product? Yeah. These prediction models can majorly help us to improve the production and to have an adaptability in process. And this adaptable production, this is the goal of Industry 4.0. And with the big data that we collect before, and the predictive analytics strategies, we can finally get this adaptive production where we are able to live react on problems, on specific customer demands, or on maintenance cases in our manufacturing. So how do we make use of data analytics to understand more of our data? One process, which we also entirely teach in our trainings that we offer for companies, is the usage of data using the knowledge discovery in databases process called Kdd process. And this process, we first start with the detection of our data, the data from our machines, the data from our sensors. Then we select the data. We select the data for the specific problem or question we would like to answer. For example, we have the question, I would like to find out when my machine needs fixing. We can select all this target data, which can be used to predict such thing. Then we pre-process all this information. We transform the data using some programming techniques, which we will also teach you, to gain some patterns, to see some rules in our data. For example, we see, okay, if sensor A is always between this value and this value, and sensor B is always higher than this value, then it is very likely that there is a problem with my machine. When we can find these patterns and we can find this structure of data, then we can finally do the interpretation of these and take appropriate measures. For example, the fixing of a machine, the restart of a production, or the adaptation of a currently ongoing manufacturing process. Practical example. Yeah. In the end now, I would like to show you a practical example where we can actually see how this all works in practice and how we can use all this to achieve a real added value in our factory and in our manufacturing. And this project we performed what's called high pressure die casting 4.0. High pressure die casting is a process where melted steel, or in this case melted aluminium, is pressed in a form with very high pressure and very quickly. This way we can actually produce optimized components. Here, the high pressure die casting was used for car component. And the situation in this project was that all the knowledge about the process was with the humans. So the people had gained a lot of insight and a lot of understanding about the process throughout the last 20, 30 years. The process has not much changed since then. Most of the data aggregation, which we had, was paper-based. That means people are writing down a lot of information on papers. It's difficult to analyze this data. Most of the process knowledge was based on human experience. So how do we create an Industry 4.0 factory in such a brownfield? This is a perfect example for brownfield here. So the goal of our project was to create a data-driven production which is able to optimize itself through artificial intelligence. So why was it necessary for this process? Well, the big problem in this process was that each time there would be a failed product, we have a downtime from half an hour because the machine needs to stand still. This is why the factory owners, they wanted to have a algorithm which can detect, based on the data that we measure, based on the temperatures, based on the pressures, based on the environment data, how to predict if the product which is currently produced is going to be a good product or a bad product. Such a prediction model can only be achieved if all the maturity steps before are ensured. We have our computerization, we have our connectivity, we have our data visibility, And then we can go in the integration of the data, start our predictive model building, and then finally get the result. We have a prediction machine that will tell us the current product based on the data is going to be good or bad. So how do you start such a project? The initial situation was, of course, as mentioned before, that it was a highly experience-based process with a lot of manual use and a lot of personal applications and experience that was in place. So the first step, of course, is to gather, consolidate, and store all the data which we can later use for analysis and training and predictive model generation. The second step is to analyze this data and use so-called model training to derive such predictive model to provide in-process decision support. That means we would like to have a model which measures all the data from the process and then tell the people who control the machine which button to push. For example, based on the prediction, the product will be maybe good or bad. So the first step is the consolidation of all this information. So what we did first is we looked at all the systems that we have, the measurement systems, the control systems, the quality management systems, and we tried to extract all this manually documented information in a digital way. So we let the people use systems rather than paper-based. We developed web applications where the users can easily type in their information, for example, using a tablet or a smartphone. Based on that, we created this little databases, which you see on the right part of each of the segments, and the measurement systems, the control systems, and the quality management systems. Based on that, we tried to integrate all this data into one database, which you see on the top right, the data warehouse. If we have this data in this data warehouse, then we can finally try to find correlations between the different systems we have here. We can find correlations between measurement and quality data. So how did we do the integration of the data to bring them all in a coherent model? For this, we used so-called Opc Ua Information Models. And Opc Ua is one of the most promising interface standards for Industry 4.0. We have, by the way, a full week seminar where we deeply learn how Opc Ua and information modeling works, how you can put together all your machine-to-machine communication data into one coherent database and one coherent data view. These information modeling capabilities were actually used here to integrate all this information from the measurement systems, from the control systems, from the quality management systems into one database that we can finally try to derive a prediction model to predict our product quality. So how would this be done in the next step? So now we are in the second step actually, where we analyze the data and try to train suitable prediction models for the in-process decision support. So first of all, we collected a lot of data. We collected data over months from the high-pressure die casting process. We had a lot of measurements. Based on these measurements, we had a lot of historical data, which had process data, measurement data, and of course quality data, which we can then use to train a prediction model. So how do you train a prediction model? You look at the measurement data that you have, temperature 1, temperature 2, temperature 3, and the pressures and so on, and you have the actual quality outcome of the product. Now you use an artificial intelligence machine and you give them all this data. And the AI machine should learn patterns in the data that correlate to high quality or low quality. If this AI machine has seen a lot of these data samples, it will finally be able to tell you, based on this data which we have right now, I'm able to see it will be a good product or it will be a bad product. So this is what we're trying to achieve here. And on the right, you see the so-called prediction matrix. Yeah? The prediction matrix shows us if products will be good or bad. Yeah? Here, IO means okay, and NIO means product is not okay. Yeah? And when the product is not okay, then we also would like to see why the product is not okay. For example, in a melted steel process, there can be trapped air in the steel, which is called blowhole. This makes the material unstable. We would like to know this not later after we have produced it, but already directly after the shot of the melted steel to be able to take appropriate measures before it's too late. So we try to develop such a predictive model, such a prediction model, using modern AI technologies called machine learning to forecast the product quality of each of the components. But the success, firstly, were limited. That means we didn't have the appropriate prediction rate that we targeted. Although we used many different machine learning algorithms. Yeah, random forest, which is a complex decision tree algorithm, or we used neural networks. Yeah, we used a machine learning technique which is called k-nearest neighbors, and all this difficult and very complex machine learning and AI models were not able to bring the accuracy above 86%. We were not happy with the result and tried to dig more into it. And as I said before, one major characteristic of the process was that most of the knowledge was with the people. It was with the people who've been working there for 20, 30 years, who understood the process deeply. So we talked to these people to find out which data we might be missing. So we talked to the people and asked them, okay, which parameters are not measured yet? What do you think, as an expert, is important to understand if the product will be good or bad? Yeah, some people said, of course, weather data is important. Yeah, in Germany, actually, unlike Malaysia, we have seasons. That means winter and summer is a very different weather. In winter, there's very much different humidity, temperatures, and this affects any factory process which deals with die casting and melted steel. So what we did is we created a weather station. We collected this data from this weather station, and we retrained the model with the new data. We tried to get better. However, we didn't really get better. We just got 1-2% better maybe, but we were still not happy with the accuracy. So we kept talking to people till we found this one person who was 60 years old and working there for 30 years. And he told us he can hear it. He can hear from the shot of the melted steel with high pressure if it's going to be a good product or a bad product. So we believed him of course, because he was an esteemed employee, which was working there for many years and was an expert. And based on his assumption, we installed sound sensors, body sound sensors in the machine hall. And most importantly, we gave this person, this expert, 2 buttons. The first button he had to press when the product is going to be good. And the second button he has to press when the product is not going to be good. Based on his data, which he personally typed in, and based on the sound data, and in combination with the data we already had before, our weather data, our pressure data, our temperature data, we did some feature engineering, did some retraining of the model, and did some extended model classification, and we finally achieved an prediction accuracy of 95%. So this is a very, very good example of why the human being plays such an important role even in a highly automated process like this Industry 4.0 factory here. And this is also very important why you need to learn how all these systems work. Yeah, and you need to learn how Industry 4.0 is deployed in your company and understand the basics of data generation, data integration, data analysis, and finally prediction to make also your production better. With these words, thank you very much for your attention. And we open to questions now.
Okay, thank you so much, Dr. Hoffman. All right, sorry for the short gap just now because we have a connection problem. But okay, yeah, that was a very good talk. I hope that everyone have kind of benefited from your talk. We have a question with us right now. Okay, one of the questions here is okay. This is from Monitor ERP.
Yes.
Okay. So how do we tackle people or personnel adaptations into this new pillar of Industry 4.0, right? So understand that reskilling and upskilling people is the way, but managing people behavior to adapt these new technologies has become a challenge, right? So what can we do for people to be more aware and accept new technologies to be competitive in the market?
Yeah, so I already sort of mentioned this point before. Industry 4.0 is not only about...
I can't hear you.
Um,
Okay, sorry.
I think my microphone is still on.
Right. Okay, yeah, sorry.
So I already mentioned this before, but I think that Industry 4.0 is not only about the technology. Industry 4.0 is also about showing the people the benefits which they have from Industry 4.0. And when we can show the people that with solutions of Industry 4.0, they actually have a higher influence on their daily work, and they have more responsibility, and they can have a bigger impact on what they do and what the company does, then we can also easily convince the people why it's good to use the solutions in their daily lives. Does this answer your questions? If you have a more specific question, then I can maybe talk more specific, but right now I can only stay on this general level.
Right. Okay. Thank you. I hope it answers the question. It was from Monitor ERP, so if they have
Okay.
any question, they can actually send again. Right now, okay. Another question. So in general, right? So let's say now in current pandemic situation, right? Um, so how can we like or how do we start now? And what would be your advice if, say, SME, for example, right? How can we like embark into industry 4.0?
Yeah, so how could an SME start right now? Yeah, we have right now the problem that not so many people can be in production. Yeah, that we have distancing rules, that we cannot really come so close to each other. But we could also try to use this as a sort of chance. What we could do, for example, is we could provide a basic training for the SMEs and show them how they can start to collect some data. We can think with them together which machine interfaces they already have, and we could maybe develop a little solution where they can start collecting machines from data which they don't have right now. Yeah? What we can, for example, do, and what I already did a lot with companies, is we can program like a little device, like a CPS device, which we can use to obtain some machine data or some sensor data and store this into a database. What the SMEs can do right now is they can use the capacity of the people to build up their knowledge in how to gather data and how to store data and how to visualize this data. This would be my advice for the first steps.
Yes, I agree because I remember there was one slide that showed that the first thing is the data and digitalization, collecting data, and all sorts of things, right? Until we become a cyber physical production system, right? So I think, yeah, it would be the best time for now in moving into digitalization first to collect all the data, right? Okay. Yeah, and another part or another understanding about Industry 4.0 is the digital twin, right? So right now, in this current situation, I think industry, if we have a production system that is having a digital twin, would be really beneficial. So this can be an eye opener for all of us, right?
Exactly.
Okay, okay, we don't have much questions, be it in Webex and also Facebook Live. So since we have more time still, probably if anyone have, anyone in the chat, if you have any question, you can actually turn on your mic and you can actually raise your question if you want to Dr. Hoffman.
Yes.
Please introduce yourself, right?
Yeah.
Anyone?
Please feel free. There, I see a lot of people in the presentation. Please feel free to ask questions. We still have a lot of time, and I would be glad to answer them.
Right. So Dr. Hoffman is an expert in Industry 4.0. He's attached to RWTH Aachen University. RWTH Aachen University is a pioneer in Industry 4.0 from Germany as well, right? Uh, since he's here, so why not you guys use the chance to ask him a lot of questions to understand better, because I can bet that he could give you the best advice. If he can't, at least he will get back to us, right? Anyone? So it looks like we have a all right. So that's fine. I think for today as a first talk. Okay, yeah. Right. That's okay. So there's no question also. Right. So we thought we had a question in FB Live, but we don't have. Right. It's okay. So since this is the first talk, right? So I think moving forward we'll have more talk, because this is more like an introduction of Industry 4.0 and how could we start during this time, right? And to all the audience or to the listeners, we actually this is a series of webinar talk where we have 5 parts, right? The first part is today, and then tomorrow will be the second part, right? The second part will be discussing about. Right. So let me share my screen. Sorry for that, Dr. Hoffman. Right. Okay. Right. So tomorrow will be this, right? So introduction to mission to mission, and cyber physical system, getting your equipment ready for digital transformation, right? So you can actually scan the QR code and register now, or also you can go to the link provided and register. So as Dr. Hoffman explained, so digitalization and collecting data, making your mission digitalized, talking to each other, and then doing the data analytics and so on is the actual process of moving or embarking into Industry 4.0. So we have actually organized a talk in that manner as well, right? So tomorrow, Dr. Hoffman will be with us together at the same time, but yeah. So, but discussing on different topic, introduction to mission to mission, and cyber physical system. So feel free to join, and please also get your friend or share with your network to ask them to join and ask understand from Dr. Hoffman and ask him a lot of questions, right? So he's actually willing to spare some time for us and giving a series of talks, right? Instead of making it one day, we are making it a few sessions because we want you guys to understand better and go back and digest the information that is given, right? All right. So with that, I think thanks, Dr. Hoffman. See you again tomorrow, and we appreciate your time for being with us today. Hopefully, for all the audience, the talk has benefited you guys, right? So this talk is brought to you by Steerix. Steerix is an authorized partner of RWTH International Academy from Germany, right? right? So together with us, MPCE, PN, NGCC, and NSSVC supported us, right? So don't forget to join our second part of the series tomorrow at the same time. So the link for feedback is in the, on your screen right now, and also you can also scan the QR code to register. Right? So if you need any assistance or further information, kindly email us at info@steerix.net. Okay. Thank you, everyone.
Thank you very much.
Thank you.